Okay, so what we're doing here is we're factoring using synthetic division along with the rational root theorem. So we're going to factor as a polynomial that looks like this. The rational root theorem can really be used on any polynomial. You generally want to use it when you have a long polynomial like this one. So, step one, always look for a GCF. In this case, it looks like we do have a GCF of 2 since these are all even numbers. So pull out that GCF first. Okay, now this is a little bit easier for us to actually factor. So at this point, all we really need to worry about is factoring the part in between the parentheses. We don't really need to worry about the 2 right now. We just need to make sure that it goes on our final answer. One tip that I like to use for this is to kind of point to the 2 and just kind of make an arrow down, knowing that you need to put that back on at some point later on. Okay, so from here, we're worrying about factoring this guy. Now, to factor this, we're going to use synthetic division. And to limit or kind of narrow down our possibilities for factors, we're going to use something called the rational root theorem. Now, what the rational root theorem does is it allows you to find possible zeros for that solution, any rational zeros that would exist in this if it were an equation. Okay, so from here, what we need to do is find a list of p's and q's. Now, what p represents is all integer factors of the constant term. So when we're talking about the constant term, we're talking about that number right there. Now Q represents all the integer factors of the leading coefficient. And that would be this number right here. In this case, it's the number 1. So, when we make a list of P and Q's, and we're talking about their positives and their negatives here, we're going to list out all the factors of 24 along with their negatives. Now I'm going to use this plus or minus, and I'm going to put parentheses behind it, meaning every single member of this set here, we're including the positives and the negatives. So factors of 24, listing them out here. And then the factors of Q, you just have the number 1. Now, we need to compile a list of what are called rational zeros, possible rational zeros. And to do that, we're going to list every single possible P over every single possible Q. So we make that list like this. We do rational zeros. We're going to say possible rational zeros. And to do that, what we go ahead and do is we list every single combination of plus or minus P over Q. And to get that list, all I'm going to do is just go through here and go 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, etc. And if I had another number here, like it went 1 and then 2, I would go, after I did that list, I would go 1 over 2, 2 over 2, 3 over 2, 4 over 2. And anything that repeats after it's reduced, I just wouldn't include in my list. So here, our list of P's over Q's is technically 1 over 1, 2 over 1, etc., giving me just 1, 2, 3, 4, 6, 8, 12, and 24. This one's actually a nice one because they're all integers. We don't have to worry about fractions in here. Okay, so when we're about to do the synthetic division here, we have to pick numbers from this set. If it factors, that means that possible or rather the actual zeros for the function or the equation would come from this list, and then we can actually factor from there. So what we're going to start with is picking the number 1. In fact, we need to have a plus or minus here. We're going to start with the number 1 and using synthetic division for this. So at this point, we're still trying to factor this polynomial here. And what we did was we made a list of possible zeros over here that we're going to try and use to synthetically divide this polynomial here. So I'm going to just go ahead and start with simple numbers like 1, negative 1, 2, negative 2, and just go up the list that way. There's no reason to jump over to 24 as your first possible zero. So what I'm going to do is off to the side over here, I'm going to create a synthetic division box. And what I'm going to do is go ahead and pick x equals 1 from this list. So I'm picking 1 from this list to go ahead and use as a synthetic division. Now the numbers I place in this top row of this box are the corresponding coefficients from this polynomial. So I use the numbers 1, -2, -13, 14, and 24. Now to perform synthetic division, you do the following steps. You first drop down the first number outside the box. So I have a 1 outside. Then you multiply this number times this number to get this number here. So 1 times 1 is 1. Then I add this column straight down, so -2 plus 1, get to this point. Then I repeat this process. I multiply 1 times -1, put that number here. Then I add and continue the process. Now, what you're looking for is this point right here. If it's a 0, then this number will factor into this polynomial. However, because this number is not 0, this actually will not benefit us at all. So I'm going to go ahead and cross this one out. If you're using pencil, it's easier just to erase these and then start again with this fresh polynomial up here. So 1 didn't work, so I'm going to try x equals -1 at this point. Okay, so as you can see, this one did come out to have a 0 at the end. So what happens is I get a new polynomial here. That means x equals -1 can divide evenly into this polynomial here. So what happens is now this is actually the coefficients of a new polynomial. This represents our constant term. This represents our x to the first power, our x to the second power, and our x to the third power. So you're going in backwards order there. So our new polynomial here Alright, so we get a new polynomial from this that I just have written over here. This, however, we need to create our factor out of this. So what I'm going to do is I'm just going to go ahead and add that 1 to the other side here. So this means that this factor is x plus 1, and that goes over here. So we've now factored that out. In fact, that 2 that's right here still belongs on the outside of this. I'm still just going to keep this on the outside. It's still there. Okay? Now, I need to factor this guy, and because it still isn't quadratic, I still have to use synthetic division again. So I need to set up a new synthetic division box and use another number from my list of p's over q's. Now, any number that did not work before, like the positive one we used here, is still not going to work. So you just continue moving through the list. So now I'm going to use a new synthetic division box using the coefficients of these numbers here. And this time I'm going to go ahead and try x equals 2. And so continue going through this process. Right, and that did go in evenly. So now again, this is our constant x squared. And from here, this factors to become, and then I need to rewrite this as x minus 2. That's our factor that goes right here. And continue to list all factors of the polynomial, even that 2 from the very beginning. Okay. At this point, I can use synthetic division again. I can divide this polynomial using synthetic division. However, your goal is usually to get it down to a quadratic, because quadratic equations or quadratic trinomials are much easier to factor. So I'm just going to go ahead and factor this one very quickly. And now I have fully factored this polynomial using synthetic division. Okay, it can be a little time consuming. It just depends on how quickly you find the numbers that will go into it evenly. Okay, from this point, go ahead and pause for a moment and try these following two problems.